optimization. So our process with the optimization, we are trying to identify our variables, and if we have multiple variables, we have to rewrite it in terms of only one, so that then we can come up with the thing we want to maximize or minimize. And to do that, you do your derivative and set it equal to 0. If we are talking about how this is related to business, we could talk about costs, revenue, those types of things. We know the cost function, C of x, is the cost of producing x units of a certain product. Then marginal cost, we've talked about that before at the very beginning when we first started talking about derivatives, is the rate of change with the cost. It tells you how the cost function is changing. So the marginal cost function is the derivative. Of the cost function. And we have done that before. So you have your cost, you find its derivative, it tells you how the cost is changing. If you're dealing more on the marketing aspect, you also have to figure out how to set your price. So if we do lowercase p of x for the price per unit that a company can charge, then that is also sometimes called our demand function or price function. We would expect it to be decreasing. So in other words, as you produce more, you're probably going to charge less per item for those. Revenue is price times quantity, x times p of x. The number you sell times the price of each one is the revenue, the amount of money you're bringing in. Of course, then the derivative of revenue would be your marginal revenue. If I want to relate this to my profit, what is profit? What does that mean? The money you make. How do you find it? Okay. The amount of money you're bringing in minus the amount of money you're paying out. So we usually use capital P for profit, and it is just the revenue minus the cost. Marginal profit, again, is just the derivative. If I talk about marginal anything, I'm referring to the derivative of those things. Look at a problem. Suppose the cost of publishing a book is $10,000 to set up the press run, plus $8 for each book printed. The publisher sold 7,000 copies last year for $13 each. But sales dropped to 5,000 copies this year when the price was raised to $15 per copy. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed, and what should be the selling price of each copy to maximize this year's profit? Okay, so we have a lot of different information here. Let's start out. First thing I told you about was the cost. We could write an equation for this. C of x equals $10,000. Is that a one-time thing or a recurring fee? A one-time thing. It's like your y-intercept. And then you pay $8 for each book. So 8 would be like the rate of change, the slope in this. Okay, so our cost equation is just 8x plus 10,000. $8 for every book plus 10,000 to set up the press. Okay. Then I'm giving you information about this stuff. What's happening based on the price. Okay, so if I'm trying to figure out an equation for my price, we have to write it as an order pair. X would be the number and then of copies, and then Y would be the price. So when we sold 7,000 copies, the price was 13. When we sold 5,000 copies, the price was 15. Then we should all know, how do we write our equation from here? Y2 minus Y1 over X2 minus X1. So my slope is negative 1 over 1,000. Now you pick your slope at one of your 2 points and plug into y equals mx plus b. So I'll just do the second point and slope. So 15 equals negative 1 over 1,000 minus 5,000 plus b. So my y-intercept is 20. So that means my price equation, lowercase p is price, is negative 1 over 1,000x plus 20. What am I trying to maximize or minimize on this one? Maximize profit. So profit is revenue minus cost. I have my cost, but I don't have my revenue equation yet. So we need to find that first. Okay, revenue is price times quantity. It's the number of items you sell, which is X in our scenario, times the price of each one, which is my price equation. So my revenue equation is negative 1 over 1,000 x squared plus 20x. So now we can do profit. Profit is the amount of money you bring in, which is your revenue, minus the amount of money going out, which is your cost. So my revenue, negative 1 over 1,000x squared plus 20x, minus my cost, which was 8x plus 10,000. I distribute my negative, add like terms, I get to here. So if I want to maximize this, what do I do? Derivative. So if I break down my 2, I get negative 1 over 500 x. Derivative of 12x is 12. We want to know when the derivative is 0. Multiply over my 500, and x is 6/7. So I asked a couple questions. I asked how many copies should be printed. And X was the number of copies, so there should be 6,000 copies. And what should be the selling price? So I need to sell them at, I need to go to my price equation, which was right here. And if I plug a 6,000 in there, and we get 14. So we should have print 6,000 copies and sell them at $14 each. Any questions there? I put it into the price. Put my 6,000 into that price equation. Other questions? So that one involved everything. We had to do cost, price, revenue, profit, all of the equations. Let's look at another one. A store has been selling 200 Blu-ray disc players a week at $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of units sold will increase by 20 a week. Find the demand function and the revenue function. How large a rebate should the store offer to maximize its revenue? Demand function is the same thing as the price function. Okay, so I'm not mentioning anything about the cost to make these Blu-ray players, so we're not worried about the cost. I don't mention profits. We're not worried about any of that. We are just finding the price and the revenue. So our price. Let's see if we can get some order pairs. X has to be your quantity. So when I sell 200 of them, the price is $3.50. Okay, to get my second order pair, market survey indicates that for each $10 rebate, the number of units sold will increase by 20. So how many units would be sold? 220. What would the price be? $3.40. $10 rebate means you're dropping your price by 10. Okay, so if we find our slope, -1/2. Take one of my points, I'll just do the first one. Slope, plug into y equals mx plus b. Intercept is 450, so my price equation is -1/2 x plus 450. Now I want revenue. How do you find revenue? It's X times the price. So if I run an x through this price equation, I get a negative 1/2 x squared plus 450x. Okay, this time we want to maximize the revenue, so now what do? Derivative. And set that equal to 0. And x is 450. Okay, now we have to answer the question. I wanted to know how large of a rebate. X is the number of Blu-ray players that we're selling. So we know we're selling to 450 of them. If I want to find the rebate, then let's find the price first. So if I plug 450 into my price equation, we get 225. So to find your rebate, what was the starting price of these Blu-ray players? And now we're selling them for 225, so if you subtract those, you get 125. So we need a $125 rebate here. Questions on that one? I want to do one last problem with you and then just give you time to work on your own. Okay, we need to design a cylindrical can with radius R and height H. Soup can type thing. So our height here is H, and radius is R. The top and bottom must be made of copper, which will cost 2 cents per square inch. The curved side is to be made of aluminum, which will cost 1 cent per square inch. Find the dimensions to maximize the volume of the can if the total cost is to be 300 pi cents. Okay, so I'm trying to maximize volume. Volume of this is the area of the base, so pi r squared times the height, which is h. Before I can do this derivative, I have to get rid of one of those variables. So that's where the cost comes into play. Okay, the top and bottom are going to cost 2 cents per square inch. So that's based off the area. The area of the top of this, it's a circle. So every circle is pi r squared. How many of those do we have? 2. So for the top and bottom, we have 2, the area is pi r squared. And if I'm going to figure the cost, how much does it cost to make that? 2 cents. My 300 pi is in cents, so I'm not going to put 0.02, I'm just going to say 2. So I'm taking the area at the top and bottom times the cost to make them. Plus, the side only costs 1 cent. So I'm just going to do 1 times the area of my side. Now, if you have a soup can and you take off your label and unfold it, what shape does it make? A rectangle. So we have to think, if I cut off this label and unfold it, I'm just talking about the area of a rectangle. Area of a rectangle is length times width. Okay, the length of this, when you cut it and unfold it, the length is the distance that went all the way around the circle. Does that make sense? So circumference. Circumference of a circle is 2 pi r times the width of it, that's just my height, which is h. And this costs 300 pi. You with me so far? So we can solve this for either r or h. Which one would be easier? Probably h. Okay, so 4 pi r squared plus 2 pi r h equals 300 pi. So I'll subtract over my 4 pi r squared. Then I have to divide by the 2 pi r h. Oops, sorry, by the 2 pi r, because we're solving for h. Could I simplify this at all? Could reduce a 2 and a pi out of everything. Okay. So that's my h. So now we can come over to our volume. Pi r squared times the h. Could reduce an r out of everything. So I get 150 pi r minus 2 pi r cubed. What's the next step? Questions? We want to maximize or minimize, so we're going to do the derivative. Derivative of 150 pi r is just 150 pi. Derivative of 2 pi r cubed would be 6 pi r squared. Set our derivative equal to 0. Square root would normally mean plus and minus, but could you have a negative radius? No, so our radius is just 5. So the question was to find the dimensions. So the can must have radius 5, we were in inches, and height. How will I find the height of it? Go to your h right here and put in your 5. So 5 squared is 25, minus 2 is 50. So we get 20. Questions? That is our stopping point. So on Friday, I gave you 3, 5, 7, and 15. I'm going to add a few more to that. We can now, let's add 33, 59, and 61. I want all of this due tomorrow. Tomorrow I have made another practice combining locales and optimization, so we're going to have a work day with that practice piece. As I told you on Wednesday, we're having a quiz, but it's counting for test points. So we're going to take a day to review before that, since